question number 7 from C4 June 2015 GCE paper. 7 part A, express 2 over P times P minus 2 in partial fractions. So here we have a fraction made up of a product of linear factors in the denominator. So you can split it up into 2 parts because there's 2 factors. So you can split it up into, so you have 2 over P times P minus 2. You can split it up into A over P plus B over P minus 2. Now what we can do here is we can multiply both sides by P times P minus 2. P minus 2. Okay, and there, this over in this side, the P times P minus 2 will disappear. So you got 2 is identical to, this is like identity, and the P will cancel out from this term when you multiply it. So you're left with A times P minus 2, and here the P minus 2 cancels out, so you're left with B times P. Okay, now what we can do, let me just make some space here. Okay, so now what we can do is we can solve this problem in different ways. Okay, what we can do is we can say let P equals 2. Well, let P, if when you put P equals 0, okay, this side you'll have 2, and you'll end up with A times minus 2, which is minus 2A, and this P equals 0 will cause this to disappear. I chose P equals 0 because I know it will cause this to become 0, this term, and you're left with A is equal to minus 1. Minus 2 divided by minus 2 is A. And you can also say let P equal 2, in case that case this will become 0, and you're left with just the B term. So you got 2 equals, you got 2 is equal to, that's 0 plus 2B, in which case B is equal to 1. So we can say that if you want to express this in partial fractions, you can say 2 over P times P minus 2 will be the same as minus 1 over P plus 1 over P minus 2. So you can write it as 1 over P minus 2 minus 1 over P. 1 over P, just to make it look neater. Okay, so there's your A minus 1 and there's your B 1. Okay, so we've expressed this now in partial fractions. Okay, that's part A done. Part B. It says a team of biologists is studying a population of a particular species of animal. The population is modeled by the differential equation dB dt is equal to 1, so a half times P minus 2 times a cosine of 2t, where t is greater than or equal to 0. Okay, of course this has to be in radians, because when you're dealing with differentiation and or any type of calculus, integration, differentiation, and the trig functions, you must always work in radians. Okay, so anyway, where P is the population in thousands and T is the time measured in years since the start of the study, given that P equals 3 when T equals 0, solve this differential equation to show the following. Okay, so now we start off with what they gave us. dP dt equals a half times P minus 2 times cosine 2t. Okay, so we have the variables t and p here. Okay, so we want to solve this differential equation. So to solve this differential equation, what we're going to do is I'm going to integrate both sides with respect to t. So I'm going to integrate this side with respect to t. So I'll write dp dt dt, and I'm also going to integrate this side with respect to t. So I can leave the half out there. I'll have p times p minus 2 times cosine 2t dt. Okay, so here the t's cancel out, so I'm left with the integral of dp. Okay, and on this side I've got a half times the integral of p times p minus 2 times cosine 2t with respect to t. Now what I'm going to do is I'm going to separate the variables so that on this side I have all the p's and on this side I have all the t's. Okay, so you'll end up with, on this side, something that looks familiar, which is 1 over p times p minus 2. I've got to integrate that with respect to p. And on this side, I've got a half times the integral of cosine 2t times the integral of cosine 2t with respect to t. Okay, now, what it also says here is given that p equals 3 when t equals 0. Now there's a nice little trick that you can use when you're dealing with differential equations. It says when p equals 3, t equals 0. So what I'm going to do here, because we have to find we have to solve the differential equation to find this particular solution. So what I'm going to do here is I'm going to put here p and here t on the top, and then I'm going to put the value of p that I know, which is 3, when t is equal to 0. Now when I solve this, it will automatically find the constant for me. Okay, the constant, and it's like a nice little short way of doing it. So I'm going to do this on the next page and take this information. Okay, so to continue now, what we have to do is be very careful. Let's look back at the original question, because we had a partial fraction that looks similar to this, and let's look at actually what it was. The result, I've got it over here. See, we had 2 over p times p minus 2 equals, you split it up like this. So this is 1 over p times p minus 2. So what I can do here to remedy that is I can multiply both sides by 2, because I've got a half here, and that will sort that problem out, because it has to be the same. This has to be the same as that for it to split up in this way. So I'm going to write this as 2 over p times p minus 2. So it's always a good idea for you to always check back and to see if you know what you got here is the same as what you split up in the beginning, because there might be a little situation like that. So this here, I don't have the half anymore, and I have t and 0 and cosine of 2t with respect to t. Okay, so now this is actually a nice way now of dealing with it when you put these limits in, because they told us when p is equal to 3, t is equal to 0. So I dealt it with it because we have to make an equation with p in terms of t. So we're going to have a p and a t there, and we'll put the value of p is 3 and the value of t is 0 there. Then there's no need for us to have a constant of integration. It will automatically work out when we integrate it, and we will calculate it because it's a definite integral now. So now let's carry on. We got to now integrate this. So this can now be split up into the partial fractions that I found earlier, which is 1 over p minus 2 minus 1 over p integrated with respect to p between the limits of p and 3, and equals, and this I'll just leave it like this for now, between the limits of t and 0 cosine 2t with respect to t. It's ready to be integrated, but I just thought I'd wait for the other side. Okay, so now we can integrate. So I can get rid of the integral sign and put my square brackets. The integral of 1 over p minus t is the ln of p minus 2. Sorry, p minus, not p minus t, p minus 2. Now, normally we would write this. We would normally put the modulus signs. But as p is a population of an animal, well, it can't become negative. And we only put the modulus sign is, you know, in case this value is negative, because you can't have the ln of a negative value. So as we know that for sure it can't ever be negative, we don't need to have the modulus sign. Okay, so on this side I can just write a regular bracket, and here I can just put ln p. No need for the modulus sign. Okay, that's equal to, now when I integrate the cosine of something, I get the sine of the same thing. But if there's a function within the function which there is here 2t, I have to also differentiate that and divide by the differential of that, and the differential of sine 2t is 2. So you're going to get sine 2t over 2, and you got the limits of t and 0. So now we're ready to substitute those values in. So I'm going to have on this side the ln of, well, I'm just going to put p instead of p, so it stays exactly as it looks, minus ln of p. Okay, and then I've got to take away the ln of, now you're going to have p minus 2, which is 3 minus 2, which is 1, minus the ln of 3, equals, and I'm going to have the sine of 2t over 2, minus the sine of 2 times 0, which is 0 over 2. Okay, sine of 0 over 2. Okay, so now, so here I can combine these together by using the subtraction law of logarithms, so I can make that into a division. So the ln of p minus 2 over p, okay, and this will be minus, well, we can see here the ln of 1 is 0, okay, because the ln curve, it goes like that, it passes through x equals 1 when y equals 0. So when x is 1, y is 0, so ln 1 is 0, and if you don't believe me, you can ln 1 equals 0. Okay, so that's 0, so you have minus 0 minus ln 3, so minus and minus is plus, you're left with plus ln 3 equals, now the sine of 0 is 0, so this becomes a half of sine 2t. So this I can combine as well, because you have ln of something plus ln of something that have the same base. So I can write this as using the multiplication, addition to multiplication. So 3 times p minus 2 over p is equal to a half times sine of 2t. Now let's look back to see how we want to express it. We want to express it, okay, with an e there, and p is a subject. Okay, so let's make p the subject then. So remember, we have the log to the base a of b is equal to c, can be rewritten in index form. The base a to the power of c equals b. Now ln means ln of something, okay, the ln of a means a log to the base e of a, right? So log to the base e of this can be rewritten as, you can say 3 times p minus 2 over p is equal to e to the power of a half sine 2t. E to the power of this is equal to that. So that's the power. Okay, so sorry, that's the base, that's the power, that's the result. So e to the power of a half to sine 2t is equal to 3p minus 2 over p. Now we want to make p the subject. So what I'm going to do first is, let's multiply both sides by p. So you have 3 times, and I'll also expand the bracket at the same time. So I'm going to multiply by p and expand this bracket. So 3p minus 6 is equal to p times e to the power of a half sine 2t. Now they wanted, what they wanted us to show, 6 is positive. So what I'm going to do is I'm going to write it so the 6 will be positive. So I'll say 3p. I'll say 3p minus p times e to the power of a half sine 2t is equal to 6. And what I'm going to do now is I'm going to take out that p as a common factor. So I have p times 3 minus e to the power of a half sine 2t is equal to 6, and then I can finally divide by this bracket, and I'm left with what I had to show. So you got 6 over 3 minus e to the power of a half sine 2t. And there we have the answer which we had to show. And if you look here, that's exactly what we had to show. 6 over 3 minus e to the power of a half sine 2t. Okay, so as I said, I really like this method where you're given values and you can put the variables on top and the values you've got underneath, and then you don't have to have the plus c and all that. It automatically calculates that for you. Okay, so next it says find the time taken for the population to reach 4,000 for the first time. So we had p equals, it was what was it? Let's remember, p equals 6 over 3 minus e to the power of a half sine 2t. So 6 over oh my god, my memory. 6 over 3 minus, okay, 3 minus e to the power of a half sine 2t. Now, even if you couldn't get that, supposing you didn't know how to get that, or you didn't quite work out, you can, for part C, use what they gave you. They gave us that actually in the beginning, okay? So you can use that and you can get salvage the marks for this. So it says find the time taken for the population to reach 4,000 for the first time. Now here you got to be really careful, because a lot of people will say, p is 4,000. But if you go back to the beginning of the question, right at the beginning of the question, it says p is the population in thousands and t is the time measured in years. So p is the population in thousands. So you see, if you put p as 4,000, you're going to have a problem. It probably won't work out at all. Okay, you get either the wrong answer or your calculator won't be able to take because you're dealing with sine. Okay, so basically you got to be very careful, aware, and you must always go back and read the question. If your answer doesn't work out sensibly, always look back to see what kind of mistake. It might be something as basic as this. So here we have to make sure that we write p equals 4, not 4,000. So we can substitute that into our equation. 4 equals 6 over 3 minus e to the power of a half sine 2t. So we want to make the t the subject. So we want to make sine 2t the subject of this. So in order to do that, the first thing we have to do is cross multiply. So I can say 3 minus e to the power of a half sine 2t is equal to 6 over 4, which is 3 over 2. So we can say 3 minus 3 over 2, 6 over 4 is 3 over 2, is equal to e to the power of a half sine 2t. Okay, and this is 3 minus 3 over 2 is 3 over 2. That's like 6 over 2 minus 3 over 2, so it's 3 over 2, equals e to the power of a half sine 2t. Now I can take the ln of both sides, okay, because I want to make this the subject, so I can take the ln of both sides. That will cause this to become ln of e, which times a half sine 2t. So you can use a power rule, so you have a half of sine 2t times the ln of e. Now the ln of e is a log to the base e of e, which is 1, so that disappears, and that's equal to the ln of 3 over 2. So therefore I can say the sine of 2t is equal to 2 times the ln of 3 over 2. Okay, now because we dealt with differentiation or integration, any type of calculus, and we dealt with a trig function, we should always be in Radian mode. Okay, so we need to be in Radian mode, which we are. In this particular calculator, if you're not sure, it's going to be press shift and mode and then 4 for radians and 3 to go back to degrees. So here it's in Radian mode. So I'm going to find what 2t is. 2t is inverse sine of 2 ln 3 over 2. Okay, so 2t is going to be, so we have inverse sine 2 times the ln of 3 over 2, which is 1.5. Close the brackets. You're left with 0.9457. 0.9457. Was that right? Yep. And then we can divide that by 2. So you have 0.9457 457 divided by 2, which gives us 0.47287, 0.47287, and it says calculate the time taken, give your answers in years to 3 significant figures. So it's 0.473 years. 0.473 years.